Welcome to the Minnesota Stormwater Seminar Series, co-sponsored by the Water Resources Center and the St. Anthony Falls Laboratory, both at the University of Minnesota. I am John Gulliver, and I will introduce our speaker. My co-host, Andy Erickson, and I have for some time wanted to have a speaker on underground devices. Unfortunately, all of the knowledgeable individuals that we could come up with are associated with a manufacturer and not necessarily independent. Then Jim Lenhart retired from Contact, and we decided that he would be an excellent individual to provide a general seminar. So we are very happy to have Jim Lenhart give today's talk. Jim is the owner of Stormwater Northwest Consulting in Portland, Oregon. He is former Chief Technological Officer of Contact Engineering Solution and was technical founder of Stormwater Management, Inc., which developed the StormFilter. Jim is the named inventor of 9 US patents in the field of stormwater treatment, and he has authored over 60 papers on the subject of water quality and stormwater treatment. Jim is a professional agricultural and environmental engineer with over 30 years of experience. He has also served as an adjunct instructor of civil engineering at Portland State University, teaching hydraulics and water resources engineering. Jim also serves as a past chair of the Urban Water Resources Research Council and holds a BS in Plant Sciences from the University of Arizona, a second BS in Agricultural Engineering from Oregon State University, and an MS in Water Resources Engineering from Oregon State University. Jim also has a master's certificate, which is with a 4th degree black belt in the World Taekwondo Federation, is a certified international referee of the Pan American Taekwondo Union, and a certified SSI scuba diver. You could use some scuba divers in Minnesota these days. But today he will be talking about underground stormwater control measures. So it is my pleasure to welcome Jim Lenhart.
Thank you, John. I'm going to share my screen now. Go. Yeah. And you see my screen okay?
Looks great.
Okay, cool. Thank you for the very kind introduction. I appreciate that. The topic of my presentation today is underground stormwater control measures. And as you may know, it's a very broad subject. So I'm going to keep it at a fairly high level, but hopefully also provide you with pearls of wisdom, if you will, in terms of design, installation, and operations and maintenance. I used to actually work in instrumentation a number of years ago, and I worked with this gentleman who for probably 40 or 50 years had been installing instrumentation to control all sorts of civil works. And he said to me one day, he said, you know, half the world is underground. And so I started thinking about, when I was invited here, about all the different underground utilities we have. We have power, water, cable, telephone, any number of utilities are underground. And even though in the stormwater end of things, there's a common term used, out of sight, out of mind. If you think about it, how is it that half the world is underground and it's out of sight, out of mind? And the reality is it's not. It's just managed differently, usually through some kind of a program for operations and maintenance on a long-term basis. Alternative urban environment is, I think, was actually coined by Warren Bell, used to be with Virginia many years ago. And we really need to think about our complex underground utility networks. And on the web, I found in the upper right-hand corner of the screen is a hand-drawn, is an image of a hand-drawn utility network of an intersection in New York in 1890. And I was like, oh my God, I had no idea, even back then, how complex these networks were. Fortunately, today with our higher technology, we can look at these networks in different ways. I've had the pleasure of being introduced to like a virtual reality, or what's called augmented reality. And you can actually, given our GIS systems and our CAD systems, you can actually go out onto a street and literally peer into the pavement and see what's going on down below. So a level of sophistication is coming on board that I think is pretty impressive and will allow us to manage these underground networks more effectively as time moves on. Other thing we have to think about is service life of these facilities. Typically, they're 20 to 50 years. And whenever you're designing one of these systems, we have to be consistent with the design life of the entire development. So if you have a 50-year time life on that, you should make sure any of the underground stormwater control measures have a service life that's equivalent to the whole site design life. And the other thing I'm sure everybody's familiar with is aging infrastructure. There's a lot of, obviously at the federal level, a lot going on in terms of how we're going to deal with aging infrastructure over time. And that obviously is above ground as well as below ground. So part of the design process, I think, is really important. And another coined term is designed with operations and maintenance in mind. And I couldn't support that more. That is absolutely the way that we need to look at this. One thing I've noted in my years of experience is how we're applying different types of best management practices or stormwater control measures to land use. I think as a community, we need to do a better job of understanding how land use impacts these control measures, and then properly design the control measures in order to deal with specific types of land use. A lot of times I've seen practices in siting and access. I've seen them put in areas where, like, stick it in the middle of the road. Well, if you put a large underground filter in the middle of a road and you have to do the maintenance on that, very clearly, you're going to have to interrupt the traffic, maybe close off a street. So when you're doing design, think about what this thing is sited relative to access. I actually had one time where somebody tried to put a vault in a drive-through in a fast food restaurant. It's like, well, if you're doing the maintenance on it, how is it that people could be drive-through to pick up their fast food? Other considerations are structural, buoyancy. I've heard some interesting stories about flotation of vaults and different things. So anytime you're doing an underground structure, you have to look at the buoyancy and also look at the loads, and not only static loads, but dynamic loads. I've seen situations where systems are put, for example, a lid on a vault, an access panel was right where a bus stop was, and buses just kept going and hammering on it until it failed. So think about the static and dynamic loads. In the lower right-hand corner is a situation where an underground structure had failed. And one of the reasons is because it was designed on the edge, if you will. And so you really have to think about your factors of safety and other aspects for your structural considerations. Soil chemistry, particularly when you're dealing with metal structures, is an important aspect of design. And a lot of times I would just urge, if the designer is not familiar with all the aspects of resistivity and moisture and pH and dissolved oxygen and temperature and microbial activity, a lot of times the manufacturers have a specialist in their area that can address these type of things, and they have a deep understanding and can assist the design engineer with the proper measures that need to be taken or the materials that need to be used in order to deal with some of those issues. Some other things that I've seen over the years is hydraulics and hydrology. One of the first things you have to do is ensure proper hydraulic grade line calculations. I've seen a number of times where somebody puts a filter in and says, oh yeah, there's no head loss across that filter. Well, I've never heard of a zero head loss filter in my life. And so you really have to think about how it is that you're going to convey the water through your stormwater network. And I think you always have to assume that the system, let's say for a filter, for example, that the filter has not been maintained, the filter's clogged up, and it's basically in an offline type of situation. Most designs of treatment systems, especially, usually have some kind of a bypass installed. wrote a paper on hydraulics of bypassing a number of years ago. And through ASTM, we're actually working on some aspects of defining what bypassing is. But fundamentally, we have internal bypassing and external bypassing. External bypassing, basically some kind of a structure is upstream of your stormwater treatment device, and it allows flows in excess of what the stormwater treatment device is designed for to be shunted around so that you avoid scour protection. In this kind of case, your hydraulic grade line calculations need to account for the hydraulics of the bypassing. When you're doing the design, I strongly urge that O&M is part of the CC&Rs. Those are the covenant codes and restrictions, particularly if you're in multifamily housing or single family housing. But a lot of times, for many years, operations and maintenance of underground stormwater facilities has not really been done. It's kind of, oh, we stick it in the ground and kind of forget about it, but I think those days are over. And so addressing these issues up front is a big advantage. Longer term maintenance contracts, for example, sometimes are a requirement for an approval for different types of systems. And I would also make sure, and usually provided by the manufacturer, is operations and maintenance manuals. But at the same time, just having a standard manual for everything off the shelf is probably not a great idea. An O&M manual should be site specific with plans and specifications. So later on, if somebody's doing the maintenance and they want a cost estimate or something like that, then they have the ability to go and say, well, how many filters are here? Or how many thousands of gallons of water are being stored in there? So they can understand what it is that they're dealing with. Also, if you're a municipality and you're permitting these things and you have construction and inspection, make sure, first of all, there's adequate inspection and ventilation access. I've seen a number of instances where it's just not adequate. And provide training for the inspectors. A lot of the manufacturers can have people come in and train the inspectors on what to look for when these systems are being installed in the ground. And that can save you a lot of problems in the long run. And then also, if during the installation, you want a manufacturer's representative out there, a lot of times they come out there and do observations, not necessarily an inspection, but do observations to ensure that things are being installed correctly. So why do people put these in the ground? What are the drivers and the economics that are really causing this to happen? Well, first of all, as I discussed a little bit, is grade and a hydraulic grade line. Sometimes on a steep site or some kind of a limited site in terms of piping networks in the site, it's just not practicable to put in above ground systems. A lot of geotechnical considerations, impervious soils, clay soils, contaminated soils, brownfields, and in some parts of the United States, karst topography. You don't necessarily want water finding its way into some small holes in the ground and working its way through a network of karst limestone. Airports and heavy industrial areas, airports are very concerned about bird strikes, so they prefer to put things underground. And also runways are just, very expansive, large systems. So in order to treat that water, basically they have to detain a lot of it and then treat it slowly after the water is detained on the outlet. Another thing a term I've used for a number of years is assimilative capacity. Just if you have a natural, particularly a vegetated system, it has to be able to assimilate the pollutants that are coming into it. And some of these pollutants, for example, like oil and grease, and that's not just petroleum hydrocarbons, that could be grease from fast food restaurants and things like that, can really take a toll on a vegetated system. So that needs to be as a part of a consideration of what kind of system is going onto your site. There are a lot of life cycle cost issues that we need to think about, and life cycle costing, fortunately, is becoming more and more important versus just how much does it cost up front. So we have to look at land costs, site prep costs, and installation costs. I think a lot of times land costs, people don't understand the impact of land costs in terms of what the total or first cost is of a practice. And then the long-term operations maintenance costs. One thing that I haven't really seen is what's an acceptable level of operation. If we go back to the old 80-20 rule, perhaps if a system is down to, let's say, 80% of its design operation, then it's time for that system to be maintained. A lot of times people say, hey, how much does it cost to maintain this? Well, it's highly variable, and it really varies from site to site. So you can, in a sense, do a generalized type of estimate of what things cost. But if you really want to know, you have to know, well, how far does a Vector truck have to travel? How many hundreds of gallons of water are there? What are the local disposal costs for liquids and solids? And then you might find from one year to the next that based on the land use and based on the local hydrology and climatic conditions, those costs can vary from year to year, depending on a lot of those issues. And then there's another cost, it's called opportunity cost. And first of all, just land availability. A lot of times these systems go underground simply because there's no land available. A lot of the, particularly your fast food restaurants and other types of things, they have kind of a fixed footprint that they need to operate within. And if they shoehorn in a site, there's really no room to put in an above ground type of facility. Another thing that's we're seeing more and more is retrofit. Well, you said, if you don't go through a retrofit program, we're only slowing the rate at which water quality is degrading. If we want to improve water quality, we have to go back into, excuse me, we have to go back into the existing infrastructure and start cleaning that water up. And that's kind of what's happening. We're seeing more and more retrofit, and a lot of that's been driven by TMDLs. Obviously, the initial land cost, but it's also loss of revenue. A commercial and retail space, for example, a lot of times the footprint of the building is tied to the size of the parking lot. And if you have to reduce the parking stalls because you're putting in an above ground facility, that means your building footprint's a little bit smaller. And if you look at the economic revenue that's pulled in by this building on a square foot basis, the cost of losing 4 or 5 parking stalls, for example, over a 20-year lifespan can be an enormous amount of money. And for public facilities, loss of the tax basis. Actually, what got me started in this business 30 years ago was a pond was being installed at an intersection, which is now downtown Tualatin. And they were going to put in a pond. And the cost of that, had to purchase the property, and then that property would be taken off the tax rolls. We put in an underground system, and they've been able to develop that property, and then the municipality gets the tax basis from that development. And also zoning. For example, here in the Portland area, there's a push to, along the light rail corridors, to have denser multifamily housing in order to facilitate the transportation structure. So there are a lot of different drivers why it is things are going underground. Obviously, these, particularly the stormwater treatment system, detention, retention, infiltration, are under the umbrella of a regulatory environment. The phase 1 and phase 2 permitting is obviously a huge driver, as well as TMDLs that are coming in the state of California, for example. They have a zero trash TMDL. And so that causes a huge demand, if you will, for different types of underground devices that can take trash out of the water. But local, state municipalities need to set design standards. So they determine, based on local data, based on the water quality objectives, what kind of treatment volumes are we going to treat? Is it the first 1 inch of runoff, the first 1.5 inches of runoff? And that tends to be kind of more on the East Coast because the storm intensities are much higher. So they tend to treat volumes versus flow. But on the West Coast, because of our less intense storms, of course, these days they're getting more intense all the time, we tend to treat, design more treatment flow. So you treat some return period, or based on a continuous modeling, you treat up to a certain flow, and you have a practice, if you will, that you size based on that flow. And we also have different pollutants that we're looking at. And most of these underground devices are looking at total suspended solids, phosphorus, and metals up in the state of Washington, but not many other places. But if you start seeing what's going on with the EPA and funding and things like that, there are a lot of emerging pollutants, microplastics, PFAS. I just saw that $25 million was budgeted in order to start doing PFAS, and EPA is starting to talk to municipalities on their permits about doing monitoring for PFAS. And everybody knows what happens when you're done with monitoring. Next thing you know comes, well, okay, now how do we get it out of the water? So in order to support this regulatory environment, there's a number of different programs that have been established over the years. And the first thing I want to point out is the difference between a verification and a certification. So a verification is basically a statement or a review of a report or a study that's done by a verification entity. A certification, so you have basically a report that's verified, if you will. In other words, if you read this report, you know through this verification agency that what you see in the report is true. And then the certification is done by a state or local municipality. And the reason is because states and municipalities, first of all, they're the decision makers, whether they're going to allow something or not. And second of all, they have their own specific issues they have to deal with in terms of sizing. There may be some operations and maintenance aspects that they need to deal with. For example, certification may be, okay, we're going to accept your technology, but you have to have a 30-inch manhole versus a 24-inch manhole in order for maintenance access. So there is a big distinction between verification and certification, and that still allows the power for decision making for the municipalities. There's two different programs that I'm going to talk about that are existing programs. The New Jersey Department of Environmental Protection and NJCAT, New Jersey Corporation for Advanced Technology, have developed protocols for the past, guys, probably 20 years now, that use laboratory-based verifications in order to study different technologies. And that basically are hydrodynamic separators and filters. The state of Washington has their technical assessment for products ecology, and that looks at field verification. So you literally have to go in, develop a quality assurance project plan, and monitor a best management practice or stormwater control measure over a period of usually a couple of years in order to verify that it meets their requirements for total suspended solids, for phosphorus, and for metals. More currently, and I think Seth Brown talked about this quite a while ago, but it's the STEP program, that's stormwater testing and evaluation for products and practices. The STEP program is actually really getting off the ground. It is now under the umbrella of the National Municipal Stormwater Alliance. And we actually had a kickoff meeting the other day, and this program is getting started. And the whole idea is it's going to be a nationalized verification program, and it's going to basically incorporate protocols and processes that have been developed through NJDEP and state of Washington's TAPE program. The STEP is going to be very tied in, utilizing the ASTM, American Society for Testing Materials, or ASTM International, for the establishment of these standards. And I'm proud to announce that ASTM has started a new main committee. It's ASTM E64 for stormwater control measures. There's a number of different standards we're working on: definitions, sediment and PSD specifications, protocols for laboratory verification of hydrodynamic separators, a test method for trash removal devices, and that actually may be through STEP, the first verification process that's being done. There's also a filtration lab test method, and field testing of stormwater control measures is in development. So we're not just looking at manufactured treatment devices with ASTM E64. We're looking at a whole broad array, including media specifications, media testing. How do you know you're getting the right bioretention media, for example? What kind of test do you need, just like you do for strength testing for concrete? infiltration test methods in order to establish if something is still infiltrating or not. So there's a lot of opportunity through ASTM to start setting standards and really help make sure these facilities are installed correctly, designed correctly, and being operated and maintained. So what does lie beneath and above? By the way, a green roof is not always in sight. You know, you kind of, is there a green roof up there? I don't know. But so as part of a whole process, it's not only just what lies beneath, but what lies above as well that we need to think about. So underground, there's inlets, sumps, water quality vaults, hydraulic control structures, oil water separators, hydrodynamic separators, filters, detention, retention, cisterns, pumps, and controls. And they are all over the place. Trust me on that. So I'm just going to give a brief overview of these different types of devices. Hydrodynamic separation. Basically, it uses settling and swirl concentration. It's usually focused on solids of 50 to 70 odd microns. So things like road grit and things like that. They're very effective at removing it. They're also, depending on how they're designed, can remove floatables. Some of them are kind of a hybrid, if you will. They settle out the solids as well as can screen out to trash and debris. These types of systems have impacts on hydraulic grade lines. Some designs actually increase the hydraulic grade line by creating a backwater in the pipe. So basically, as the water comes down a pipe, there's a weir or an orifice or some kind of structure that allows the water to kind of back up in the pipe, and that starts settling the solids out. And then the solids are basically, as they organize, they move down into a sump. And when you're doing your HDL calculations, you have to assume that that's what's going on. Scour protection, again, bypassing is very important, discussed that earlier. But the big thing with hydrodynamic separators, try to avoid hydraulic jumps. I've seen a lot of times where you have a settling device, if you will, or if you think about settling, you want some fairly quiescent, organized flow, and a steep pipe will come in. If you have supercritical flow coming into a sudden enlargement, you're going to get a hydraulic jump. And hydraulic jump is basically the dissipation of a large amount of energy. So a lot of times, if you're looking at designs, you try to come in at least subcritical flow in order to reduce the incidence of hydraulic jumps. Some other things I've seen, some issues I've seen with a lot of people think you just come into these things and suck all the dirt out, or the sediment out. But a lot of times you get cementation in the bottom of these systems. There's just a natural process, and sometimes people decide it's a good place to dump stuff like asphalt or something like that. So you have to make sure, to a certain extent, you have access to the bottom of these things. Don't assume that you'll never have to access it and go in there and with a jackhammer or whatever and chip something out. Trash and debris is actually getting a big resurgence. Trash and debris is typically defined as objects that are greater than 5 millimeters. And again, that's being driven by a lot of TMDLs, particularly in the state of California. There's 3 basic types, inlet types, with catch basin inserts and baffles. Actually, catch basin inserts were some of the first stormwater control measures that I remember back in the early 90s. And then they kind of died off, but they're having a resurgence, and we're seeing a lot more applications where people are using these inlet type of to capture trash and leaves and debris and everything else. So they have to be maintained fairly frequently, and sometimes they're also very good for a pre-treatment to larger underground facilities. There's in-pipe systems, netting systems. Some of them use hard screens, some of them use netting systems. And then there's also inter-pipe netting systems, like you see in the lower portion of that photograph. But some of these photos give you an idea how dirty that water can be. I think a lot of times we think, oh yeah, stormwater, it's got some total suspended solids, 100 milligrams per liter, maybe some phosphorus in it. But the water, particularly you look in these underground systems, it's very frequently, it's not pretty. There are a lot of filter products out there, and there's literally tens of thousands of these underground throughout the United States, in the world for that matter. And one thing I just wanted to point out quickly is filtration processes. A lot of the filters that you see, particularly underground systems, are operating on the order of 100 inches an hour. So, and you think about, let's say, bioretention, that might be operating at 6 inches an hour, 10 inches an hour. So how is it that you can get something that's operating at 10 times faster? How is it that you can get to performances? If you think about it, it doesn't make a whole lot of difference or a lot of sense. But if you start getting into the different filtration processes that are going on, it does make sense. So a lot of your underground sand filters, for example, or bioretention, biofiltration systems operate on a process called cake filtration. It's where you build up a kind of a Schmutzdecke, if you will, of solids, and that literally becomes the control. And that's one of the reasons that they're operating at a much slower rate. And the media mix is much finer. A lot of the underground filtration systems use a depth filtration. So rather than forming kind of a cake at the top, the particles go through a media, and as they travel through the media, they're subjected to all sorts of processes, if you will, that settle these particles or entrap these particles onto the surfaces. The difference is when you maintain a cake filter, you kind of scrape off the top and you can help restore it. With a depth filter, if it's full of solid, you have to completely replace the media. So there's upsides and downsides to both processes, but you can get very good results using both of these processes. If you look at how these filters are sized and designed, typically they're fixed head designs. So once it gets a certain amount of head loss, it goes into bypass or overflows. Typically filters are flow based. And so if you want to treat a volume on a flow basis, you have to have kind of a standardized hydrograph, if you will, in order to translate what a flow is to a volume. But there are also volume-based filters. If you, I don't know, yeah, I'm assuming you can see my reticle here, but so there's a volume-based system design, if you will. We do a lot of these on the East Coast. So you basically take, let's say, the first inch of runoff, you store it in a detention pipe, and then it bleeds out of that pipe through filter system over a period of time. So this helps reduce the number of filters that you have, because you don't want to be treating a peak from a type 2 storm. You don't want to be doing it. One of the issues you have with volume-based storms is somebody will say, okay, I've got a 10-acre site and I've got this detention system in front of it, and I'm going to bleed that water out. So for this 10-acre site, I need one filter. But the filter still has to treat some of the solids. And so there's what's called a mass-based design. So what you do is over a period of a year or a maintenance cycle, you estimate how much water is going to run off, what your treatment percentage is, what your mean event concentration is, and that calculates a load. And if you have load studies that are done on the filter, then you can say, okay, maintain this thing once a year, you're going to need 6 filters, versus on a flow basis, you might only need 2 filters. Pre-treatment is not done very often, and I think my opinion is over the years is that pre-treatment for filtration systems is a good idea, particularly when you're high traffic roads in areas with a lot of trash and debris. Keep that away from the filters and pre-treat that, and that will significantly increase the life of the filter and reduce your maintenance cost on a long-term basis. Different types of filtration processes. When I first started in this business many years ago, there was only a couple of ways you did it, but now there's all sorts of ways to do it. Horizontal bed filtration is basically where, like a sand filter or an iron amended sand filter is done in Minnesota. You just pond the water on top. You've got a pressure diagram, pushes the water through at a certain design flow rate. They're canister filters. Some are just operate off of gravity, and you get kind of a triangular pressure distribution. So you have a much higher driving head pressure at the bottom than you do at the top. They work okay, but with a non-uniform pressure distribution, you can have rapid accumulation of solids at the bottom and none really at the top. You have siphonic systems. A number of different products do this, where you basically develop a hanging column of water in the system, and you have a negative pressure on the inside, positive pressure on the outside, and you get a uniform pressure distribution, which helps for uniform treatment and extends the life of the filter. And now you have membrane filters and some others. I started thinking about all the different filters, and there's a lot of different ways that are being done by different companies. And this kind of goes back again to the verification process. I think it's always good to make sure if you're specifying a filter, make sure it's been verified through one of these processes. Filters have media, and there's a lot of different properties to the media. There's physical properties. So you look at gradation, you look at roughness, porosity. For example, perlite is used a lot. Those are little white granules that you see in bottom soil, and has to be handled carefully. It has to be screened, but it's a very effective filtration media. Chemical properties, you have absorption properties of different types of media that are put in. And one that's probably looked at the most, cation exchange capacity. So media like zeolites and certain carbons have the ability to exchange lighter elements such as sodium, calcium, magnesium for heavier metals such as copper and zinc, which are regulated in a number of places throughout the United States. Another thing I really want to stress is make sure you're not specifying toxic media. I've seen instances, yeah, this stuff is great for taking the metals out. That's because it's using a surfactant. And when the surfactant goes out, it exhibits aquatic toxicity. So anytime I think it's a regulator that somebody is using a different media, you say, hey, have you done some freshwater or saltwater testing on this using EPA standards to ensure that whatever it is in the media, even though it may be getting out one pollutant, you might be releasing another. And I have seen that in the past. So it's important to understand all the aspects of what this filter media is. Environmental stability. I've seen situations where, yeah, we use like the pulp newspaper that's treated. Well, once that gets in stormwater and you get the bacteria going at it and it stays saturated, it decomposes, and you look down in there and say, hey, where'd my media go? Just as for the information, if you're interested, D.WRE has established a stormwater media filtration committee where we're looking at the different types of media, the aspects of media, and I think it's going to be an important production by D.WRE. So you start looking at all these different technologies and you ask about treatment and performance and longevity. And people used to talk to me a long time ago that getting 80% TSS was a big deal. And I said, well, that's a probabilistic statement. I have a certain confidence that I'm going to get 80% of the time, I'm going to get 80% removal, but I'm not 100% confident. But I said, yeah, but I can guarantee you I can get 100% TSS removal. And they're like, how's that possible? That's not possible. I said, it is, because I'll use TSS filters as my filtration media. And by definition, I'm getting 100% removal. And then it will be, yeah, but those things clog up really fast. Aha, that's it. So it's not just about performance for filters, it's also about longevity. And more work needs to be done on how long these filters will last, so we can understand how frequently they need to be maintained and what those long-term maintenance costs are going to be. And no, Santa, there are no zero head loss filters. I had never heard of one of those. And I've heard people stating that, but I've never actually seen one in reality. Also, filters have a loading capacity to them. And there's some processes which look at silica versus natural stormwater solids. And direct your attention down here. We did some studies on a filter fabric. And on one side of the fabric, which was the upstream side, you can see we had loaded it with natural sediment, which was this thing that looks like chocolate pudding down below. And we found it clogged it up very quickly. Whereas if you look on the downstream side, which is kind of the white dusting on there, those are actual silica particles that we had loaded ahead of putting the natural stormwater sediments. So the silica would kind of go through, and we really didn't see, if you look at this graph, we loaded quite a bit of silica on there, and we didn't see hardly any decline in hydraulic conductivity of this fabric. But as soon as we loaded the real stuff on it, we just saw a rapid decline. And one of the reasons is natural stormwater sediments have bacteria, they have organic matter, they have clays and silts, which are not spherical. They have a charge and they're platy. And you develop these biofilms on there because you've got nutrients, you've got organic carbon, a lot of other things. So I think we need to better understand how it is that filters deal with real stormwater sediments versus natural silica. And the reason we use silica is because everybody's using the same thing, but if it really is not applied to what goes on in the field, then sometimes I question the veracity of that. Filters sometimes can fail because of surface clogging or occlusion. A lot of times occlusion, which is like internal occlusion, is a natural process, or it is a design process, and when occluded, it needs to be maintained. That's kind of the way it works. Surface clogging can be catastrophic. It can cause the filter to fail very quickly, and that's what we want to try to avoid. Biofouling is a big problem, so if you're in areas that you have a lot of grease, fast food restaurants and things like that, you have to be aware that biofouling can occur very quickly. We've been talking in the past about a turkey timer. How do you know when the filter is done? How do you know it's not doing this or doing that? And there is some work at looking at some type of process, but it would be good to have a turkey timer that just something pops up and says, hey, it's time to do the maintenance on this thing. Moving on, talk about detention. There's a lot of different ways to detain water. Corrugated metal pipe has been used for many, many years. There's people out there who tell you all the advantages and disadvantages. I'm just going to do a couple of quick things for corrugated metal pipe, which is not just galvanized. It can be galvanized, aluminized, or it can be aluminum pipe, depending on what your needs and things are. But it is very strong, customizable, lower costs. And a lot of the nice things, a lot of the manufacturers will actually design these for you or have design tools to be able to do it. One thing I wanted to point out, this little third grade drawing, which I did, is about my extent of CAD drawings that I do. I saw this in Australia. It's pretty interesting, called a buffet tank. And the water on the inlet side comes to a small chamber. And so it fills up very quickly. So you go from to your maximum design flow and your detention very quickly. And once it gets to your design flow, then it spills over into the rest of the detention tank. And then once the storm subsides, the little flat valve opens and then allows the downstream side to drain out. This allows you to reduce the size of your tankage by on the order of about 30%. The thing you need to watch out for is shear stress duration, because you basically are developing a square wave hydrograph, if you will. And you have to establish whether that's a good thing or not based on the receiving waters, based on your storm network and a few other things. So it's a clever way to reduce costs and manage your water, but you have to be careful how it's deployed. Newer products are steel reinforced polyethylene pipe. It's fairly lightweight. It has the benefits of plastic and steel, so you can get very large diameter plastic pipe. But you have to be careful in installation, and it's used a lot in reline projects these days. A lot of concrete detention. One thing that I like about this is full maintenance access, as well as you can get with large diameter pipe as well. It's typically optimal for heavy loads and deep profiles. And usually the way that it's cost out is how many dollars per cubic foot of storage is it going to cost you. There's precast and cast in place with a lot of different foundation options. And the nice thing about the precast is fast installation, particularly if you're doing an underground infiltration facility. If you're doing cast in place systems, you're going to get a lot of heavy equipment traffic. You can get concrete spillage and a number of other things that can threaten the infiltration capacity of a system. I would also recommend, you can see the extent of some of these systems. Some of these things are monsters, but to provide a sedimentation area in the system, essentially it's a pre-treatment. So you have to go in and pull out a lot of sediments. You're not having to go the entire system, just a smaller portion of the system that's going to reduce your long-term operations and maintenance costs. It's also plastic systems. Some people call them milk crates. There's also the plastic arches. They're lightweight, they're inexpensive, and they're very low profile. So if you don't have a lot of hydraulic grade in your site, this is a good option. You do have to be careful on the structural system. There have been some structural failures, and I would say, particularly along with the, well, I'm not the point is you don't design these things on the edge, right? You have to make sure that you allow some latitude, if you will, for the installation and other aspects of the system. If you design it on the edge, you might have a problem where you get a structural failure, and nobody wants that to happen. Properly designed, they're good products. Another thing I don't particularly care for about a lot of the low profile stuff or the crates is maintenance access. If you have to get in there to maintain it, it's really hard to do. And you're kind of doing it blindly, if you will. Retention and infiltration. First of all, when you're designing, you have to know your subsurface infiltration rates, the initial rates, the operational rates. Just what happens is you can have that stormwater coming in, and even if you have a low total suspended solids, once it hits that surface where the infiltration is going to happen, that's where you're going to develop a layer of solids, and that ultimately can become the restriction or the throttle, if you will, on your infiltration. You get too much in there, particularly you get biological biofouling, you can get a total failure of a system. And it's incredibly important to protect it during construction. I've seen underground infiltration systems that fail from the word go simply because a bunch of construction sediment got in there during the construction process. Keep the systems offline. In fact, I would keep all systems offline until the site is stabilized and ready to go. I also recommend, and this is something I've been fighting for years, but it's really hard because nobody's requiring it, is protect your subsurface with some kind of a treatment. A lot of times infiltration facilities are protected with the HDS unit, but it's not the coarser particles that you're capturing in your HDS that are really doing the damage to an infiltration facility. It's the finer solids, and it's the stuff that's only going to get out with the filter. And I look at it this way: you want either to filter the stuff at the infiltration interface, or you want to filter it upstream with a filter that you can maintain. And so maybe someday as we move along, we'll find out that if you're going to do infiltration, you got to filter it upstream with filters that you can actually maintain. Another thing is some interesting research done by a gentleman, Clay Cashett, and he did a lot of work on void stone. So a lot of times these big infiltration systems will, you put in a perforated pipes, and then that's all in a bed of stone. In the stone, the voids of the stone actually become part of the volumetric calculations of the amount of water that you're capturing and then infiltrating. And he did a lot of work on void rock specifications. And I just have a few graphs here, and this is one of them. But he basically said everybody's just assuming that the void space is 40% on the rock, and he found that's just not true. And so we need to be able to understand what that actual void space is. You're putting something in the ground for 20 years, and you get the accumulation of solids in those void spaces. You can slowly over a period of time lose that volume. And he found out that it's 83, if you want like about a 38% void space, there's an 83% likelihood that you're actually going to get that with your stone. He also did a lot of research on the fines associated with the stones. Imagine you have an infiltration facility and you put in some dirty rock and you get a big storm. Where's all those fines going to go? They're going to go right to the interface. Some other interesting things going on. Supplemental irrigation. I mean, if you think about above ground bioretention, for example, here in Portland, we have a very dry summer. So the city has to go around and literally water these things or install an irrigation system up front. Well, that isn't exactly the best thing, if you will. So I have this green infrastructure there that's reducing heat island effect and taking up some carbon and benefiting, has all these environmental benefits. And then somebody drives in a truck and takes potable water that's treated and puts it in the truck and then drives around and waters these things so they don't die during the dry period. So there's an opportunity there for different types of technology to store this water and use this water for irrigation, for fire control, earthquake preparedness. So there's some interesting things going on. Real-time controls that I know Marcus Quigley presented here, and that's also becoming a pretty interesting way to manage water. And a lot of those controls are going to go underground. So your valves, your controls are all in there. In fact, I think it was in Minnesota, very large. The stadium there has a monster rainwater harvesting system and a big underground treatment facility in order to use that water for irrigation and I think potable water, at least gray water. So operations and maintenance, asset management, and this comes back kind of full circle onto the out of sight, out of mind. The only way you can manage these things is asset management. And this is becoming a more important time with the advent of the GIS systems, information systems that we have. A lot of municipalities are starting to include software and things in order to manage these as assets and not forget about them. And that goes for all facilities, not just underground facilities. Green roofs, bioretention systems, swales, ponds, wetlands, and underground systems all need to be done through asset management. There needs to be inspection and enforcement. A number of municipalities, they have inspectors that go out and say, hey, this thing's overgrown or it's full of sediment and you got to get it cleaned out. And until you do that, we're not going to, well, it'll be enforced, put it that way. There's actually a photo here of the world's ugliest catch basin. I think in New Zealand, it was a contest who could take the ugliest catch basin picture. And it kind of reminded me of a Jackson Pollock picture. Also think about for access, the surface access, confined space entry. If any of you recognize actually the inaugural presenter, that's Bill Hunt in there doing a little vault diving and having some fun. Some inspection basis. First of all, know before you go. A lot of the manufacturers will provide you guidelines and also keep databases on the systems that they have provided, and they can give you a lot of information, and there's nothing wrong. They also provide training. They'll bring in people from municipalities or private maintenance contractors, offer the training, and can provide specific design information, including drawings and specifications for specific sites. All systems, a lot of times people just go out and they maintain the system and say, we're done. And you really need to look at the whole site. You find out that somebody is, not cleaning the grease traps on the roof or spraying a bunch of greasy mats out in the back and all that grease runs off into the system. You can go back to the owner and say, hey, you got to do this, or that's going to rapidly or greatly increase the cost of maintaining your facilities. When you go into these systems, always look for structural issues, fasteners, ladders, joints, hinges, etc. The stormwater environment is pretty corrosive. I've always been surprised at how things can rust and corrode underground when exposed to stormwater. Also, vectors, big issue, particularly with mosquito vectors. But there's also, it's a photo there of I saw I was out on a bike ride and this rattlesnake was stuck halfway in this handhole for a water meter. I can imagine opening that up and finding a rattlesnake in there would not be a fun thing to do. So these are things that you think about when you go and do your inspections. For hydrodynamic separators, particularly you're looking at sediment depth, but also again, you got to make sure you don't have cementation and other things, because if you do, you might change your strategy. Trash and debris. You can see here that it can accumulate fairly quickly. Usually it's just take out the sediment, take out the trash and debris, but you have to clean the screens. And a lot of times, depending on the screen structure, that's not the easiest thing in the world to do. So you have to make sure you can access those screens and spray them off or scrape them off. Filters. Well, the first thing, if you open up a filter and there's standing water, yeah, it's about time to maintain it. Other times you look in it and it looks really clean and you kind of go, yeah, I don't think I have to maintain it this time around. But sometimes you're not so sure. So you can usually learn from the manufacturer again, what are the visual cues that you have as something is need maintained for a filter. But you look for things like short circuiting. Are there any broken components? And look for sediment levels. A lot of times, every time a storm cycles through, you'll see kind of a bathtub ring, if you will. And that gives you kind of a good idea how high the water, how frequently the systems has either gone into overflow or and been operated. For your harvesting and real-time controls, you go out, I think you need to test the controls. I designed a pond a long time ago, and we had a big spill gate in there, and we got a call about 10 years later, and the gate was completely frozen. And it's like, well, you have to go out there every year and you have to exercise the gate, you have to grease it up and things like that. So all those things will need to be maintained to some extent. Detention and infiltration systems, look for sediment deposits, clean those out. I would always consider that the design of detention systems be, with some kind of a treatment in them. You don't want to get a bunch of sediments in there and then have a big storm and everything race down to the end of it and completely clog your control orifices. You need to inspect those orifices and control structures. I've seen instances where the thing's clogged up, so somebody just goes in with a big crowbar or something and just smashes it. Okay, water's out now, we're all good, without any thought about the fact that those orifices are designed to control the water. Sensors are pretty cheap these days, and so for, let's say, a detention system or an infiltration system, you can put one of these little depth data loggers down in there and see, is it draining out in 24 hours is per specifications, or is it taking 4 days for it to drain down? Drop that down in there, take the data, download it, and you're pretty well informed at that point in time whether or not the system's operational. So maintenance costs, first of all, they're very site specific. So if you want a quote on something, they're going to have to say, where's the site? How big is it? How much sediment do I need to dispose? How much water do I need to dispose? But you also, particularly for your municipality, you have to think about the administration. So it's the SG&A of basically operating these systems, your equipment costs, amortization of your equipment. These trucks are running $300,000-$400,000 a pop that are running around on the roads, and they're not cheap to get out the door. I used to hear, oh yeah, it's like $500. It's like you can't even drive one of these trucks out of the parking lot for less than $500. You have to look at fuel and equipment, operation and maintenance, labor, direct and indirect labor, mobilization and travel, and disposal costs. I think that's one thing, particularly from the private sector of doing the maintenance. I've seen as high as 50 cents to $2 a gallon for the disposal of water, because it has to go through basically a haz waste type of facility. Whether the water is hazardous or not doesn't really seem to matter, but you're putting the water there because you just can't go dump it anywhere else. Solids disposal, and there are a lot of issues in terms of how is it that you separate. I wrote a whole paper on separating the solids from the liquids in stormwater, because you have all the organic matter. It's not an easy thing to do, and a lot of times it just has to sit for a long time. It has to go through some kind of a vacuum process in order to try to suck the water out. But it's not something we need to do more work on in the future. In conclusion, I stress the need for verifications and certifications. I think that's an incredibly important thing to do, meet the local requirements. We need consistent and uniform design so that people know what they have, they know what they're getting into, and every time they go into something that's not different than the one before. I've looked at asset management. It's incredibly important for budgeting. Make sure you have the proper equipment to do the maintenance and for record keeping and enforcement. I would plan for the increased use of underground technology. Earlier, I didn't mention it, but I looked at a map of population growth in the United States. And every year we have to build a city for like 400,000 people. You think about that, that's pretty amazing. I think there's going to be more acceptance for verifications and standards, and as time goes on, and I think there's going to be more enforcement, and we'll drive more treatment trains to ultimately reduce long-term operations and maintenance costs. And so that's pretty much it. Asset management is key, and I would keep that in mind. So with that, we'll go say thank you and open it up for questions.
Thank you, Jim. I think that what we'll do is move to take about a 5-minute break. Andy Erickson will lead a panel with Jim and local experts to answer all your questions after the 5-minute break.
Welcome back, everyone. My name is Andy Erickson, and I will be moderating the panel discussion. It is my honor to introduce our local experts who've agreed to join Jim to talk about this discussion of underground stormwater control measures. So we have our panelists are joining and sharing their videos. I will introduce them one by one and ask for their relation to this topic so they can introduce themselves to you. Our first panelist is Todd Shoemaker. He's a senior associate and water resources engineer at WENC, now Stantec. So Todd, from your experience and your perspective, how do you relate to this topic today?
Hey, good morning. Thank you, Andy. I guess I relate to it. I have almost 20 years experience here practicing consulting in the Twin Cities area. During that time, I've done thousands of development reviews for various municipalities, watershed districts, also performed our own site designs, many of which are using underground stormwater control measures. During that time, I've seen a transition from mainly ponds now to with a lot of my more urban clients and projects, almost exclusively underground work or underground treatment. Most recently, I have, as I've been seeing underground filtration systems, I've been curious about their performance and eventual performance after years in the ground. So I've been interested in that and have been, with the support of the Minnesota Stormwater Research Council, I've been researching those systems.
That's great. Thanks, Todd. Our next panelist is Steve Gurney, who is a water resources engineer for the city of Bloomington here in Minnesota. So Steve, from your perspective and experience, how do you relate to this topic today?
Well, hi, everybody. Thanks for having me. I relate to this kind of similarly to Todd. I've been doing this for 20 years, all aspects of it, design and inspection and permitting review, and now maintenance too. So I have a wide variety of experience here in Bloomington. We've got like I pulled some numbers, 120 trap manholes, about 24 of the hydrodynamic separators, three infiltration systems of our own, plus one that is a kind of a hybrid infiltration and stormwater management. That's actually a 12-acre-foot underground chamber of various materials. And interestingly, we just cleaned that out here recently, and the sediment forebay that we had put in there was completely full, so it was good timing. It was a public infrastructure next to a bunch of development, and the other areas kind of contributed a lot to the sediment as they were being built up. So we got her cleaned out now, and we'll see how it lasts.
That's great. Thanks, Steve. Our next panelist is Forrest Kelley, who's actually a returning panelist to the seminar series and the Regulatory Division Manager for Capital Region Watershed District. So Forrest, from your perspective and experience, how do you relate to this topic?
Thanks, Andy. Good morning, everyone. I've been with Capital Region since 2007, and we are the most highly urbanized watershed district within the state of Minnesota. We issue permits for all the development that's over an acre, and we see a lot of underground systems. I was looking through our permitting database. We've got about 238 underground systems on both public and private land. That's about 40% of all the stormwater BMPs that we have gone through our permitting program. So we do also install and operate and maintain our own capital improvement projects, just like City of Bloomington does as well. So we see a lot of different designs. We observe them going into the ground. And now that some of them are 15 years old, we are going back and looking to see how they're performing. And that's something that we want to do more of. We really need to get back on that track and see how over time they're doing.
That's great, Forrest. So thank you all for that. I'm not going to ask for Jim's relation. We had the keynote speaker from Jim. So we'll just jump right into questions. We do have a number of questions in the Q&A chat. So please, if you have questions, add them to the Q&A box. If you like questions that you see there, please vote them up, give them a thumbs up so they rise to the top. So I'm going to start with the highly voted question at the top of the list for me. It says, what are your thoughts about using shredded tires as a filter media associated with these underground structures? So Jim, the question came in during your presentation. I don't know if you want to start, and then if the other panelists want to chime in with their experiences, that would be great.
Yeah, I've seen shredded tires used before. I'd rather see them used in, for walkways and running tracks. Tires contain a lot of zinc, and I saw a paper once in Canada where they basically digested tires, and they were like 30% by mass zinc, and I can't say like it's really bad, but it does concern me, and I think probably more studies would need to be done before it became a mainstream media.
That's great, Jim. Anybody else have comments on the shredded tires?
I believe there's a professor at UW-Madison that is studying the performance of these in underground stormwater systems. So that's something to keep track of. I haven't seen any data, so maybe it's not for me to say right now, but I would be hesitant of using tires as the filtration media. I have seen them used in the past as the storage media, essentially replacing the rock that Jim mentioned earlier surrounding these systems. So I guess that's my experience with the tire shreds in the past.
Yeah, in Capital Region, we've seen, I believe, 2 underground systems, corrugated metal pipe, perforated pipe infiltration systems that used tire shreds as the backfill material, as the storage media. As Todd mentioned, I haven't seen it used as the actual filtration. We did look at the potential for that material to leach. We are monitoring one of those systems off of Energy Park Drive, and testing for volatile organic compounds. And I'll have to check in with our monitoring crew and see what that data is telling us. But we did look at some of the research, the papers out there on if it was a concern, and came to the conclusion that at this point, with them being underground and not being exposed to to UV, that they weren't breaking down as quickly as if they were at the surface. So not something that I see going very widespread, but we do have a couple of them in the district.
That's great, Forrest. That's very interesting. I can also mention that we're doing a study right now on tire-derived aggregate or shredded tires at the University of Minnesota. We don't have anything published on it yet, and none of the results are out, but you can contact me and I can put you in touch with the research group that's working on that and the researchers to find out the status. And there's actually a comment that came in the chat as well that mini tires also contain this 6-ppd quinone, which has been linked to fish mortality. So there's a number of water quality concerns related to tire material. And there are some unknowns, I think, but there is some research, as Todd mentioned, and as I mentioned, that's going on. So it's important to keep in the know of those. So I'll move on to the next question. The next rated question is, Jim, this is referring to you specifically. You recommended training for inspectors supervising installation of these practices, maybe specific additional training for these underground structures, right? So what training opportunities do you recommend for inspectors supervising installation? What specifically would you say is different about construction inspection and installation for these underground structures? And this actually will apply to our whole panel, but Jim, if you want to take that first, go ahead, please.
Well, experientially, a lot of times inspectors are not familiar with these devices at all. And despite the fact that there's plans and specifications, I've seen them installed backwards. I've seen them all sorts of different things, the inlet pipe or the outlet pipe's higher than the inlet pipe, all sorts of interesting things. Maybe the vault gets in the ground and somebody just throws them in there. I've seen them like put on pipes like popsicles. And a lot of times the inspectors, they just don't know what to look for. And back in the early days, I would go like the city of Olympia and they'd have their inspectors and say, here's what it looks like. Here's how it's installed. Here's how it works. So they understand, what to look for. And my guess is all manufacturers would do that if requested. Yeah.
Yeah, I believe that too. Do any of our local experts have some input or advice on construction inspection and for installation and of these practices?
The University of Minnesota has training programs. Highly recommend both erosion and sediment control, and then there's periodic in-field training. So there's a great resource in our backyard. So I highly recommend that, in addition to the manufacturers putting out webinars on site trainings. And there's so much variability in these systems that some of the basics will get you a long way, but then if it's an infiltration practice, you gotta be looking out for the compaction. There's filter fabric, there's rock specs. It's a lot to keep track of. So definitely, if there's a gap in the what's being offered out there for trainings, that's something that we all as a community should work on, so that we know that these systems are getting installed correctly.
That's great, Forrest. Go ahead, Steve, please.
Forrest beat me to the punch. I couldn't get my mute button fast enough, but there's these guys over at the U that made this book, and everybody should have a copy of that. One of the things to keep in mind is they are all different, and things are different in the field than they are in the lab, and you need to kind of think critically about how you're approaching these. And you may get lucky and have some that require no maintenance or very little maintenance, but until you know that for a fact, you ought to be checking them at least once a month after they're put in.
Yeah, that's really great advice, Steve. Anybody else want to add? Go ahead,
add
Todd.
to that if the installers likely don't know the intent of why this is going into the ground. So if the observation staff are also involved on the front end, doing any sort of design or permit review, that would be helpful, because then you have that connection from the why to the install.
Yeah, that's really good advice too, Todd. I appreciate that. So yeah, as Forrest mentioned and Steve mentioned, there's a couple resources out there. The University of Minnesota does have a stormwater control and erosion control certification program. I will share links with the Q&A document that goes out next week to all the participants. Everybody that registered will get a copy of that. So I'll share links for that. I'll also share links for the book that Steve mentioned and the online manual that's associated with that as well. So I appreciate that. We'll move on to the next question. So there's a recommendation for pre-treatment, right? So some devices have pre-treatment built in. Would you recommend pre-treatment in addition to that? I guess where would you choose when to use pre-treatment, and where maybe pre-treatment is redundant or unnecessary, or maybe going to be less effective, specifically for these underground structures? And anybody can jump in and start on that.
I can, I'll start. That kind of gets back to the land use issue that I talked about. You know, we have a tendency to say, you know, one size fits all for land use, and it really doesn't. There's been some attempts, for example, on high traffic roadways. The amount of sediment, the tire dust, I call it the junkyard dirt because it smells like junkyard dirt. You know, it's much higher than, let's say, a residential road. And to me, like putting in a filter that's filtering highly traveled roadway runoff without pre-treatment is an invitation to, you know, for a high maintenance frequency and high costs. So, but unfortunately, even you recommend it and people go, yeah, it's not required. And so they don't get put in the ground. And but I think as enforcement happens, people are going to go, you know, it might be a better idea to reduce our long-term operation costs by putting in a pre-treatment for different types of land use and different types of technology.
The question also went on to say, or there was a similar question asking about the sizing of the pre-treatment, and that would be very helpful to have some kind of guidelines there. You know, you're putting these systems in and spending all kinds of money. Wouldn't you want to protect it a little bit? I mean, if you have a new car, you're going to change the oil in it. You're not going to just, well, most people, but so it's just it's something that they should really consider. I echo what James was saying.
In terms of redundant pre-treatment, I don't think anyone, maybe an owner would be against it, but generally I would guess everyone on this call is not going to reject a design or ask to modify if there's too much pre-treatment. So instead of just a sump, two sumps, or a sump and a vault, or an HDS, I'm a big fan of that quote unquote, that layering approach.
Yeah, I'll say our rules require pre-treatment, but that's all it says. You must have pre-treatment. So in terms of sizing or recommendations, there's another gap there. Jim had mentioned the idea of filtering the water before you infiltrate it. And I think that is amazing. And this treatment train of, you know, really getting out that fine material before you put it back into the ground is going to make your systems last longer. But then there's the added cost to the developer, to the landowner. But, you know, maybe it's going to take some of these systems failing to really change how we're designing them and how much pre-treatment we are adding or requiring.
Yeah, I think I really appreciate that Steve brought in the sizing piece of that. You know, if you look in the Minnesota Stormwater Manual, it's really only in recent years that we started talking about what kind of performance should you expect out of pre-treatment specifically. right? So what level of performance do we want to get out of these pre-treatment? When the purpose of pre-treatment is really to make maintenance simpler, right? Some of these structures are hard to get into, right? You have to divert traffic. If you can have a pre-treatment practice that's easy to get into, easy to vac out, that's going to simplify maintenance. It's going to lower costs. You can do it more frequently. And I think frequency also gets to part of this question. If we're not doing it frequent enough, then maybe more pre-treatment is a good thing, and it's not redundant, because you have that layering. You have multiple places where sediment and pollutants can get captured. And if you miss a maintenance cycle, you're not going to fill up your actual stormwater treatment practice that's downstream, right? That pre-treatment is intended to protect. So all of that, I think, goes into this. And I really appreciate all of these comments. So the next question gets into disposal and management of water. I think it also is referring to sediment, all of the things that we're going to be pulling out of these underground structures, some of the floatables, and maybe even some of the chemicals, right, that are floatables, the oils and greases and things like that. So if anybody has comments or experience on the detail regarding the disposal and the management of the water and cleaning out everything that you clean out of these sumps and underground infiltration chambers, it'd be great to have that. And then there's a kind of a second half, so I can come back into that once we get through that first piece.
Yeah, I did. Actually, I wrote a paper and presented a paper on this in 2000, so 21 years ago. APWA, it's actually downloadable off the web. And I worked with Snohomish County and Oregon Department of Transportation on looking at residual management. And what we found in the research is primarily that the pollutant of main concern is oil and grease, petroleum hydrocarbons. And that usually what triggered disposal regulations. But there were no specific regulations in place for stormwater residuals. So they always treated it like a hazmat, haz waste. And we even found out that because of the organic matter, some guy up in Snohomish County took a bunch of pine needles and it failed the EPA test for TPH, and technically it was a hazardous waste because those regulations were developed for underground storage tank decommissioning, right? And I don't think a whole lot of progress has been made on that, but I know some progress has been made, and the cost can be really high. And separating the solids and the liquids from each other, it's not an easy thing to do. You kind of get this weird slurry that really doesn't want to dewater, and it's kind of like non-Newtonian fluid. It looks like a solid, but as soon as you start agitating it, it just liquefies. And it's a problem. There needs to be a regulatory structure for it. But we did find that, except in one case, that was a TPH that was really the driver for disposal.
What about our local experience? If anybody wants to try to tackle that.
I know the solids we send to DEMCON, one of the local landfills. I don't think that's a very good long-term sustainable solution, and I kind of cringe every time I send pond excavation there as well. It'd be nice to find a way to keep that out. Granted, they can use it for their daily cover, but there's probably other things that they could be using. So let's find a way to reduce that.
I know.
Actually, go ahead.
Well, in St. Paul, the Green Line corridor has a large number of tree trenches and large number of stormwater sumps. And Ramsey County was having a lot of difficulty in that material, and it wasn't your sand and slurry and grit, it was trash. And separating that material out, like Noah's question on skimmers, where these pre-treatment systems are designed to capture those floatables, That gets that can clog a vac hose. It's solid waste. It needs to go to a landfill, and it's totally different than dredging a pond where you've got PAHs that needs to be sent to landfill. I believe Ramsey County was able to take that material to their yard, let it dry out, and then ship the actual solid waste to a landfill. So that's a tough one.
Yeah.
And I working with a gentleman that has developed an onboard treatment system, if you will. So what it does is you start looking at some of these sumps. I mean, they can have thousands and thousands of gallons of water in them. And you don't, first of all, be hauling those back and forth over the roads and having to dispose of that. So it isn't like an onboard treatment system that has actually gone through testing and has an MPDS, mobile MPDS permit.
Wow.
Where you basically can suck it out and you take the water, you run it through a treatment system, almost drinking water quality, and then you can reuse it for washing, or you can put it back in the sump, if you will. Particularly in a lot of places where you have like CSOs, with an inverted elbow, it's acting kind of like a P-trap, keep the gases out. So you want to kind of refill these things with the water, and really reduces the hauling costs and disposal costs. So there are people working on this, and I'm just seeing more and more. I'm seeing a lot of companies emerge that are, let's say, more than just suck it up kind of thing. They're much more professional in terms of the way they're looking at it. But the disposals needs to be evaluated and I think regulated.
Did you want to jump in on that, Todd, or no? Nothing to add? Okay.
Nothing to add.
Good. So yeah, and that's I think that's the big challenge with this, right? Is we're dealing with debris, right? So gross solids, large debris in our floatables in some cases, and like Forrest was saying, that's trash, right? But then we also have floatables that are liquids, oils and greases, as Jim was mentioning. And so and then of course all the sediment, right? And any part of that can get contaminated with any other part of that. So it's a cocktail that's very difficult to deal with. And I feel like I agree with what Steve was saying. We need some better options for how to deal with this long term. So the next question actually gets to private ownership of some of these devices. And do you have any examples, or do you have any advice for our audience for how to get private owners of underground systems to perform their regular maintenance, or even just perform their regular inspections? Sometimes I know some private owners, they just contract out the maintenance, right? So that's one option I've heard. But what other options, or what other advice or examples can you give about getting private owners to take care of these underground systems?
I can start off again. A really good example is McDonald's that we worked with many years ago. And yeah, you need to maintain this thing. It was, I don't know, back then, let's say it was like $5,000 or something like that. And the guy's like, oh my God, that's terrible. What we found out is if you say, we'll sign an annual maintenance contract and it's going to cost you $500 a month, they're like, great, because it becomes part of their budgeting process, a monthly expense, and they understand. But if they get hit with I saw one in the city of Vancouver, they had a pond that was totally out of spec, over $100,000 to reconstruct it. And the owners didn't even know it was there. So I think, first of all, the owner, making sure the owner knows it there, and whoever is operating the property, maybe responsible, knows it's there. Offering maintenance contracts that come in, I think is a big help. Yeah.
I'll continue on I guess kind of on the private side, and then maybe Steve and Forrest can jump in on the public side. But I would say that I think as Jim's presentation showed, we have there are many underground options. So as designers, I think it would be beneficial to involve the owner as part of that design process. And this is what we're thinking. Here's one way we can do it. This is where your maintenance is going to be. Not if you're going to maintain it, here's what you do is, but you're going to maintain this. Where do you want to maintain it at? What are your operations? How can we, as someone mentioned earlier, the drive-through, how can we minimize any interruptions to your site operations?
Yeah, and I'll build on what Todd said. And then I lost my thought. Sorry, we require a maintenance agreement, and it's not anything that we've done ourselves or started ourselves. The watershed districts kind of came up with it first. I question, having been on both sides of the aisle, how much of that is getting communicated to the owner. We as the professionals need to make sure that they do understand what they're getting into, not just signing a box so they can get their permits. It's a big thing that I feel we could do better on.
Yeah, I'll add to that as well. It's so the watershed district does require a maintenance agreement to get recorded with the property, so that as properties change hands, we've got the legal mechanism to ensure that it does get maintained. However, it falls back on the watershed district to follow up with these landowners to say, are you maintaining your system? And most of them are not. I can count on one hand the number of annual reports we get from private developers. We require a maintenance plan and that's in the past 2-3 years, something new that is, it's not an agreement that says, yes, we'll maintain it. It's, this is what you need to do to maintain it, so that document can be handed over to the landowner or the maintenance team that's out there. We need, it's been mentioned, but we need to make that connection, not only with the developer on the front end, but those landowners. We need to make that connection now, so they know that it's there. Maybe not most, but oftentimes they don't know that it even exists. And Jim mentioned something that I thought was very interesting that I think should be considered, is requiring a long-term maintenance contract up front before you even issue the permit. Show me your contract. Show me the vendor that you're going to use. What's the annual cost? And that is something that we have looked at for certain BMPs, but I think we need to expand that and consider that.
Yeah, I think I agree with that too. And I want to also reiterate what Jim mentioned about it, just making it a monthly fee. I know some cities, maybe even some of the watershed districts, in lieu of trying to get enforcing a maintenance contract that a private owner has to implement the maintenance and that, they just say, you know what, we'll take it on. We'll do the maintenance ourselves, and you'll just pay us a flat fee on a regular basis, whether that's per year or per month or whatever it is. And it just take it completely out of the private owner's hands, and just making sure it's getting done. So that's another approach that I know is happening in Minnesota in certain places, in certain jurisdictions. So it's still a struggle, and it's a challenge, and that's where we always have this mix of public and private, right? So our next question actually targeted a little bit to Forrest, but it also applies to everyone, I would say. What do we know about how well pretreatment is performing on these underground infiltration and, I'd say, filtration systems? Do we have good data on that? Is our pretreatment worthwhile? Is it actually saving us money on maintenance because they're easier to maintain? What would you say towards that?
Well, I can speak to the systems that we own, because I know that they get maintained. It's working in terms of focusing where you do the maintenance. You've got your swirl separator, you got your sumps, and you go in and vac those out. Now, is it working to prolong the life of the infiltration system? That is up for debate, and we'll see in the future, right? we can pre-treatment right now is designed to capture the large particles. And that's not what is going to make a filtration BMP or an infiltration BMP fail. It's the small stuff, it's the clays, it's the silts. So there's room to improve on pre-treatment for sure.
Yeah, there's some research by Monash University where they did some studies, and they're showing particles in the order like 20 odd microns have the biggest impact on filters. And in some past studies on a volume-based filtration system, so we're storing the first inch of water in a large detention system and bleeding it out through the filters, it was amazing how much pre-treatment occurred. And one of the recommendations is if you do have that pre-treatment, you can add a credit, if you will, if you're doing a load-based designs. And the filters last a long time. And but you gotta, so much of the solids are settling in these pipes that, but you still got to pull those out, but the filters last a long time.
In our work on the underground sand filter research, I think all of the systems we're monitoring have pre-treatment. We have noted that I would say maybe half are being maintained regularly, at least probably once a year. That's kind of weird to say, is regularly is once a year, but that's probably the best we can expect for these days. But what I hope to do is try to correlate that pre-treatment or lack thereof with the filter performance items that we're measuring and the data that we're collecting.
And I think it's important, Jim mentioned in the presentation, it's not the super coarse sediment that's clogging up the filter media or the infiltration soils, right? It's all the fine stuff. So again, getting back to some of the very early questions, when you're trying to design and select pre-treatment practices, you got to think about that. What are you removing with your pre-treatment, and what impact is that having on the performance of whatever you have downstream, right? Those are very, very important questions. Any other comments on that question?
Yeah, Andy, you just made me think of something that in terms of selecting pre-treatment, I think it's relatively new. It's a relatively new tool from the PCA. If it's not new, I apologize for not knowing about it sooner, but PCA has a pre-treatment selection tool that can be linked from the stormwater manual. We have probably 50 different pre-treatment sort of tools or options. And this tool refines that based on your site conditions, so instead of considering 50, it'll narrow it down to like 10 to 12, something like that.
No, you're right. That is a relatively new tool that's out there, and I'm glad you mentioned it. It is important for this discussion. Any other comments before I take the next question?
I'll just
real quickly. A lot of times we always focus on TSS as kind of the solids, but there's so much more going down the pipes. Some of the early research by Roger Bannerman, for example, God bless him, but he so much of the solids are saltating toward the bottom, and they're not being picked up. And I've seen systems where you got a 50 milligram per liter TSS, but the system's just buried in solids. There's a lot more stuff going into these systems than is just simply accounted for by emit mean concentrations of TSS. A lot more.
Forrest, go ahead, please.
Yeah, I'll just add that of the infiltration systems that I know have failed, they were due to mistakes made during construction. That's not to say that we don't have some out there that are holding water longer than they should, and were constructed correctly and worked when we closed the permit out. That is within the next few years. We need to start now. Go back, look at these systems, pop the manholes, look under the hood, see what we're seeing.
Yeah, that's really good advice.
Forrest cut something that I had come to mind to me is the construction cleanup. Jim mentioned in his presentation, keep the systems offline till after things are established. I couldn't tell you the last time I saw a system that actually did that. We've gone and actually inspected the pre-treatment systems prior to signing off on building permits and found probably 80 to 85% had some needs for clean out.
Yeah, I can believe that. I could certainly believe that. So I want to go back to, I actually missed a question that tied in with the private ownership question. And the question is there a list of companies that can help private owners perform regular maintenance or various stormwater systems, like these underground structures or ponds even? And I'll mention before anybody jumps in, I mentioned it before, it came up earlier as well. There is an inspection and maintenance certification course that's offered through the University of Minnesota. And we do maintain a list of everybody that's gone through that course. So that includes many of the companies that perform maintenance and inspections even of underground structures, above ground structures, basically any kind of stormwater control system that's out there. So there is that list, it is available. And we can share that. But it's giving you a list of people that have gone through the course and have been certified to do inspections and maintenance. There are a few other resources out there for finding companies that can do this type of maintenance, but I'm curious to see what our local experts have to say. And Jim, if you have anything to mention too as well for this, we'd really appreciate it.
Yeah, I would, again, refer, if you know what the particular device is or the manufacturer, call them on the phone and say, who do you recommend? And I'll go back to company I work with. They provide maintenance training like every 6 months, and they bring in private operators throughout the entire United States. And they have certified maintenance providers for the technology that do that. And that'll be another good resource to check into if you know what the device is that you're trying to work on.
Other recommendations?
There are, I would say, probably several companies here in the Twin Cities metro that provide, I think, what they consider to be, they call themselves industrial services companies. They have the equipment that's ready to go, many times for emergency situations, fuel spills, other sort of big catastrophic things, but they also do regular sort of maintenance for clients. So that would be one way to go.
And I won't say specific names, but there's some I call emerging companies that are specializing in O&M of stormwater control measures above ground and below ground. So they understand bioretention design and plant specifications and media specifications and things like that. So they're not landscape maintenance contractors. They're stormwater quality management facility. And then also they do all the underground stuff. And those companies are growing and they're putting on a lot of seminars and things I've been watching. And it's pretty interesting to see them growing. So.
We get the question quite often. I believe we have a list of local companies that do the cleaning. I'll have to see if it's been updated, but if there's interest and it's appropriate, I can provide that.
And I think that would probably be good advice for really anybody, right? If there's a private owner and, contact the city that they're within, contact the watershed district if they're within a watershed district, or even depending on where they're at, it might be at the county level that some of this stormwater management is organized. Reach out to those local jurisdictions and see what their experience is, because many of the cities, watershed districts, and the counties have their own infrastructure, their capital projects that they put in themselves. And so they have either they're doing the maintenance themselves or they're contracting it out. So they're going to have good advice for what's worked well for them too. So the next question, we have a comment suggesting, requesting, I guess maybe would be a good way to phrase this, welcoming a seminar focused on discussing pretreatment and experiences specifically for biological, bioretention, bioinfiltration, and filtration systems. So that's something we can certainly add to the list of seminar topics for the future. But another question I want to ask, we have a bunch of questions. We're not going to be able to answer all the questions. But before we get kind of into the closing, I want to talk, I want to back up and kind of go big picture. And I want to get our panelists and our keynote speakers' impressions on our biggest challenges and limitations related to these underground structures. We've talked a lot about specific things, but what are our big problems right now? And how might we begin to address them or overcome them? What would you say for that?
Well, I think it's a two-pronged approach. First of all is verification and certification. You know, I think the more that we have a level of confidence that these things do what people say they're going to do and understand the operational parameters, I think that's the upfront hurdle. And I think the on the downstream side of it is operations and maintenance and asset management. I don't think people understand how many of these things there are in the ground. I mean, there's hundreds of thousands of these things in the ground, and they're going in more and more every day. And it's going to have to be managed just like the utility company manages their power vaults or the water vaults or whatever it is that they do. That's got to be the ultimate thing in order to achieve the goals, which is clean water. That's the true goal.
I think we've talked a lot about the educating the owner and just making the owner aware of that. But besides that, one thing that Jim brought up earlier was regard to bypass. And as a designer, I think that's one thing to understand, and maybe it's hard to understand, is how, if bypass is provided, how does that relate to, how does that impact the pollutant removal performance of the system?
Other big challenges or limitations you see with these underground systems that we need to start addressing and overcoming?
With the reliance on infiltration and volume reduction, we're gonna come up with a problem of the chlorides getting in our drinking water, and how do we avoid that? Not to mention the other pollutants. I know some work has been done on capturing some of the heavy metals and such, but it really would be helpful to have a foolproof method of getting rid of chlorides, but put that on the long-term wish list, I guess.
I think it's been said before, education for the owners of clearly conveying the expectations on what this costs, and also what it's going to cost when it fails and you have to dig it up. I think we're going to see more as we start looking at them. We're going to find the ones that don't work. How do we rejuvenate the ability to clean water? That's going to be a big one. Is it digging the whole thing up and starting over? Are there retrofits? Is there cleaning that can be done to gain that capacity back? But I think the turkey timer, like, all right, it's time to do the maintenance. That's going to be a challenge.
Yeah, that's great. I really appreciate, Steve, that you brought up chlorides. We haven't talked about that yet, but that's a big concern in any cold climate where you're applying road salt, and especially with underground structures. What's the linkage there, right? And so that's certainly something we have to be cognizant of. And actually, Forrest, your comment on communicating, basically that was kind of the next question I wanted to ask is what are some of the hardest things to communicate about these underground structures? And Forrest, your insights on that was great. I don't know if anybody else has other insights or experiences on what's been challenging to communicate about underground structures. And maybe that's also linked to who has been the most challenging to communicate the information to. Maybe it's not the public, maybe it's not the property owner in some cases, maybe it's a city council, maybe it's some other governing board. So what experiences or insights have you had there that's worked well for you?
Yeah, sometimes I guess what comes to mind for me is as much as probably ourselves on the panel and the audience are familiar with these systems, even taking a step back, there are some even municipalities that don't have any of these systems installed yet, and they're coming, and they may be a little hesitant to even install one themselves. So I guess it gets back to that education and showing where these have been installed, how they've been installed, and a lot like what we're doing now, talking about the positives and negatives of each of them and what to be aware of.
I think there's difficulty in making the transition from engineering plans and the engineer to the field workers, the contractors. There's room to improve, to have consistent specifications, consistent notes, so that there's no question and no mistakes for someone who's in the backhoe, running the compactor or not. So and that goes for every single note on a plan. But I think communicating, and Todd mentioned it before, why are we doing this? What does this thing that we're putting in the ground do? Why is it important? And that will help them understand how it needs to get constructed.
It's a no-duh statement, but also the point that if you're installing a filter, it's designed to clog. At some point, it needs to be refreshed. It needs to be replaced. You got to do something. When that happens, success.
Yeah, it goes back when I was doing my undergrad. One of my faculty members said, as an engineer, everything you're doing is designing it to fail at some point, right? Everything is designed to fail. It is going to fail sooner if you're not maintaining it. But even if you are maintaining it, at some point, we have to do something with it, right? Nothing is indefinite. So keeping that in mind can be a hard message. People don't think that, right? As Jim was saying, let's build it, let's put it underground, and we don't have to think about it again.
Yeah.
So
I think, Andy, going back to the ASTM E64, I think having standards, even I know that John did some research on infiltration testing. If you look at a bioinfiltration or biofiltration, how do you know when that thing is still in spec? You have to go out and you have to do an in situ test. And having those standards, a standard test and all this other stuff, I think would go a long way to help kind of smooth take the wrinkles, if you will, out of the process from all the way from design through operations and maintenance.
yeah, that's a good note, Jim. And that actually leads really well into kind of the closing. What I'd like to do is have all of our panelists We'll take a moment to give our key takeaways or their key takeaways from today. And I'll go in the exact same order that we introduced everybody. So I'll start with Todd. What would you say are your key takeaways?
Pressure's on me. Oh, I think it was the first question that you kicked to us was redundancy, and that's has been top of mind for me over the last several months to a year as I see our own designs is let's consider different layers of pretreatment. That a simple sump catch basin probably isn't good enough. What else can we add to that, or could we add something else downstream that could target a different type of pollutant? Maybe the sump and the T or the hood that's in it is for trash and floatables. Then there's a vault downstream that does some sediment.
Yeah, that's really good. Steve, what would be your key takeaways from today?
I think we need to do a better job of understanding how these work, conveying that to our customers, if you will, the owners, etc. Monitoring so that we know how they are working and maintain them when proper. Jim talked about these little data loggers. You can get one of these for about $300. You throw it in the manhole or the chamber and come back and get it in the fall and download the data. You kind of know what the system was doing. So it's doable.
Yeah, we're living in the era of big data, right? Remote systems and all of this stuff. There's so much information that we can get access to and collect. We should be using it, right? Forrest, what would you say are your key takeaways from today?
There's so many options out there. These systems are highly variable, highly configurable, which makes it great to get away from the one size fits all approach. So, the world is your oyster, and let's get creative and design with maintenance in mind so that we can now take that next step of, it's our permitting program has been around for 15 years. I've said it a number of times, and it's something that's been on my plate and on my mind for a long time. We gotta go back and look at these and make sure they're working. And maybe there's a little bit of fear that we see all these systems failing and then what do we do? But maintenance, and designing for maintenance.
Yeah, I think it's important to go back and look at what we've done before and not be afraid to learn from it, right? We all make mistakes, and our biggest mistake is if we don't try to learn from those mistakes and adapt to new technologies and new ways and better ways of doing things, right? So Jim, you have the last word. What's the key takeaway from your perspective from today?
Well, I think everybody kind of covered it. Again, I guess I will go back to verification, and certification, and standards. There's going to be more and more of these things going in the ground. Urban density is increasing. New regulations coming by, even more sophisticated pollutants. So you're going to see a proliferation of these systems, not only in terms of number, but in terms of types of technology. I think having these upfront verification, certifications, design, operations, and maintenance are all important, of equal importance. And I guess in closing, I would also state that D.WRE has an operation maintenance conference coming up. And I think, Andy, you probably know more about that than I do. I think it's in Wilmington, North Carolina. But, and I'm sure a lot of these issues that we've touched on today will be discussed there as well. Thank you.
Thank you, Jim. Yeah, and I'll also include a link to that operation and maintenance conference that will be happening in March of next year, 2022. Abstracts are still open for that, but I believe they close on Monday next week. So if you haven't heard of that, if you're interested in the operation and maintenance conference of stormwater control measures, Go online, try to find it. If you can't find it, email me. I'll send you a link to get an abstract in if you want to present there. It will be really, really good discussions on inspection and maintenance. So with that, I will thank Jim for the keynote and setting the stage for our topic today. I want to thank Todd, Steve, and Forrest for serving as our local experts on this topic. And I especially want to thank all of you, the audience, for tuning in today, for registering and providing your questions. I apologize, we could not cover all the questions in the time that we had, but I will share all questions with Jim and the panelists and give them an opportunity to add some answers, not only more information to questions we've asked, but also answers to questions we were not able to ask. So that will all go back out to you, to everybody that registered, as well as the link to the YouTube recording when that's available. And I look forward to seeing you all at the next Minnesota Stormwater Seminar Series. For the seminar series events, we will have Bob Pitt in October, which is going to be really exciting. But first, in September, I will actually be presenting on some stormwater research that we're doing through the Research Spotlight series. So if you are not already, please sign up for our updates newsletter, and you'll get announcements for all of these events and our stormwater research that we're doing at the University of Minnesota. So with that, I want to thank you all for joining us today, and I look forward to seeing you in the next one. Enjoy the rest of your day.
Thank you.
Thanks, everyone.